Hi grade 11s, this is JP. I'm going to take you through the solutions to the quadratic equations exercise. It's in your module, not in your textbook, in the module on pages 1 and 2. It says revision exercise. So the first exercise there, they just ask you for the general term of a couple of quadratic sequences. So the first one is 2, 6, 14, 26. And then the sequence, of course, will continue. So the first thing we're going to do is we're going to look at the first differences. So what's the first difference? What do you need to add or subtract? Add a negative from 2 to get to 6. And that, of course, will be 4. And that is 8. And then that is, of course, going to be 12. Yeah, absolutely. So and what we then notice is there's a common second difference. So the first difference is forms a linear pattern. The second difference is all constant, so it's the same. So it's 4 and a 4. Right, so, and then what we just do is we say, well, 2a is equal to the second difference, right, 4. And what we're going to do is we're going to say 3a plus by b is going to be the first term of the first difference, so that's equal to 4. And we're going to say a plus by b plus by c is equal to the first term of the sequence. So that is equal to 2. Okay, so that 2a, 3a plus b plus by c, that's generic. Just look at the videos that's before this, if you're not sure where those come from. So here we go. So let's start with a. So 2a is equal to 4, therefore a is going to equal to 2. Therefore now we know what the value of a is. So 3 times by 2 plus by b is equal to 4. 6 plus by b is equal to 4. So b is equal to 4 minus 6 is minus 2. So we've got a, we've got b. Now we just need to work out what c is. A is 2, b is equal to minus 2, c is equal to, and then plus c is equal to 2. So therefore 2 plus minus 2, of course, is 2 minus 2, and that's 0. So c is equal to 2. And remember, the general form of a quadratic sequence is an squared plus by bn plus by c. So therefore it is 2n squared minus 2n plus by 2. Let's look at question 1b, 4, 9, 16, 25, and so the series continues. So what we first work out is the first differences. Remember, for quadratic, the first differences will form a linear pattern, arithmetic sequence. So what do I need to add to 4 to get to 9? That, of course, is 5. What do I need to add to 9 to get to 16? That's 7. What do I need to add to 16 to get to 25? And that is, of course, equal to 9. Yeah. And then let's look at the first differences. 5 plus by 2 is 7, and 7 plus by 2 is 9. If you're battling with this, I would suggest that you form your own quadratic sequences. Start with a number, and then try to make up your own 3 or 4 quadratic sequences from the first term. Okay, so let's go for it. So 2a is equal to the common second difference, so that is equal to 2. So so divide both terms by 2, so a then is equal to 1. 3a plus by b is equal to the first term of the first difference, so that is equal to 5. So 3a then 3 times by 1, right? We know what a is. Plus by b is equal to 5. So b is going to equal to 5 minus 3, which is equal to 2. And then the first term, a plus by b plus by c is equal to 4. We know what a is 1. We know what b is, it's 2. We don't know yet what c is, so minus 3 on both sides, then c is equal to 1. Okay, and again, Tn is equal to an squared plus by bn plus by c. So Tn is equal to 1n squared plus by 2n plus by 1. Okay, let's look at question 1e. So we've got minus 3, minus 6, minus 11, minus 18. And of course, remember, those negatives will make a difference. So here we go. What I need to add to minus 3 to get to minus 6? Negative 3. What I need to add to minus 6 to get to minus 11? Negative 5. What I need to add to minus 11 to get to minus 18? That will be minus 7. And then you notice a beautiful arithmetic sequence, linear sequence, same term you'd add to every single term of the first differences. And what is the constant second difference then? It's going to be minus 2. And let's hit it. 2a is equal to minus 2. So therefore a is equal to minus 1. 3a plus by b is going to equal to, yes, minus 3. So therefore 3 times by minus 1 plus by b is equal to minus 3. Minus 3 plus by b is equal to minus 3. Therefore, b is equal to 0. Right. A plus by b plus by c is equal to negative 3. We've got a minus 1, b which is 0, c we don't know yet. So therefore, if you minus 1 on plus 1 on both sides, then c is equal to minus 2. So tn squared is equal to an squared plus by bn plus by c. So therefore it's minus n squared plus 0n. I mean, you won't judge if you write it, but I mean, you don't really go to the shop and say, you know, do you want, if they ask you, do you want something else? And you say, yeah, can I please have 0 packets of chips or something? I mean, that's just weird. But anyway, so, and then minus 2. Okay, let's look at question 2a, 1, 6, 15, 28. So again, let's go through the first differences. 1 plus by 5 is 6, 6 plus by 9 is 15, and 15 plus by 13 is equal to 28. 15 plus by 13 is 28. So the second differences will be 5 plus by 4 and 9 plus by 4. Hey, second difference constant, quadratic sequence. So we know 2a is equal to 4, therefore a is equal to 2. 3a plus by b is equal to 5, so that means 3 times by the a we just worked out plus by b is equal to 5. So 6 plus by b is equal to 5, b is equal to minus 1. And then a plus by b plus by c is equal to, yes, 1, the first term. So a is equal to 2, b is equal to minus 1. So plus by c is equal to 1. So 2 minus 1 is 1, minus 1 on both sides, c is equal to 0. So therefore tn squared is equal to an squared plus by bn plus by c. So tn is equal to 2n squared minus 1n. Alright, then they ask you to work out, for question A, the value of the 20th term. You know, that's of course the reason why we want the general term of a sequence, to be able to know the value of a specific term, or if I give you a value, I want to know which term is equal to that specific value. Okay, so if I chuck now 20 into n, so 2 times by 20 square minus 20. Oh goodness, that square is a bit social distancing there. So then that is 800 minus 20, and that is equal to 780. Question B, so then I ask you, so which term is equal to, so I want to know which term has got a value of 3,160. That's not a question mark, that is given. And so again, the general term is 2n squared minus n. I know now what the answer is. The answer is now 3160. I want to know what n is. Please don't be strange here now. You've got a quadratic trinomial. Don't do something weird, like take out an n on the right hand side and, I don't know, it's a 0 factorial, right? Not the 3160 factorial. So 2n squared minus n minus 3160 is equal to 0. And if you know your factors of 3160, just joking, use the quadratic formula, and then you're going to get, you know, x is equal to minus b plus minus square root of b squared minus 4ac over 2a. Then n is going to equal to 40, or n is, you're going to get two solutions, right? Or n is equal to minus 79 over 2. Now, 40 makes sense. That would mean term 40 is equal to minus 3,160. I mean, so first of all, we don't really want a negative term. I mean, that's just weird to the highest degree. And then also, how do you get a term and a half? I mean, that's like asking someone to dig half a hole. You know, that just doesn't make sense. So what you just write there is not applicable. So if you've got a negative value or a non-integer, so in other words, your answer for a term, of course, should be a natural number. Alright, let's hit question 3 there. Minus 4, minus 10, minus 18, minus 28. Let's look at the first differences again. So we'll notice that is minus 6, minus 8, minus 10. Like a linear, that's great. So therefore minus 2, second difference constant. So let's go for it. 2a is equal to minus 2, a is equal to minus 1. Then what we've got is we've got 3a plus by b is equal to minus 6. 3 times by minus 1 plus by b is equal to minus 6. Minus 3 plus by b is equal to minus 6. b is going to equal to negative 3. If you add 3 on both sides, right? And then lastly, we've got a plus by b plus by c is equal to negative 4. So we've got a is equal to minus 1. We've got b is equal to plus minus 3, so it's minus 3. And then we've got plus by c is equal to minus 4. So minus 4 plus by c is equal to minus 4, schnitzel. So minus 4 plus 4, plus 4, of course, is going to be 0. Therefore, Tn is equal to an squared plus by bn plus by c. And we know what a is. It's minus 1, so minus n squared. B is equal to minus 3, so it's minus 3n. And c is 0. For those strange ones, you can put there plus 0. Okay, so then question A there asked you, what did question A ask you again? What is the value of the 25th term? So T25, what is that equal to? So what we're going to do is we can say T25 is equal to minus 25 square minus 3 times 25, right? N is 25. What do I do now? So T25, what is that? 25 times 25 is 5 to the 4, 6 to 5 minus 75. And what is 6 to 5 minus 6 to 5 minus 75? That is equal to minus 700. Okay, and then question B there, they ask you, so which term is equal to when Tn is equal to, what did they say? Minus 810. So therefore, general term, minus n squared minus 3n minus 810 is equal to minus n squared minus 3n minus n squared minus 3n plus 810 is equal to 0. It's quadratic, right? I mean, I don't like a negative leading coefficient, so I would just divide every single term by minus 1. So it's n squared plus by 3n minus 810. And what do we have then? If you can actually factorize that nicely. You know the factors of 810, don't you? So it's 30 and minus 27. But you can use a quadratic formula. So then it is n plus 30 is equal to 0, so n is equal to minus 30, or n is equal to 27. Doesn't make sense for the term value to be minus 30, not in this context. I mean, that doesn't make any sense. So therefore, what does this mean? Term 27 is equal to minus 810.